Let's see here. Pop out that chat. Pop it out. Chat, pop out. Let's go. Loading up, loading up. Hey, what's going on, everybody? I'm not really feeling this one. Let's just throw it back. The OG one. The OG one. Yo, Prism, Austin! Hello! Welcome back, soldiers. How you guys doing? Welcome back into the stream. Hope you guys are having a good day so far today. Today is July 30th for me, 7 p.m., 7:06 p.m. Right on the money here for starting the stream. Appreciate you guys for joining me here once again. It's going to be a good stream today. So, yeah, welcome. Today, we're going to be solving problem set 1 of MIT's 6.0002 course, Introduction to Computational Thinking in Data Science. We're going to be starting solving, hopefully today, and completing the problem set 1, Space Cows Transportation. So hopefully this isn't too bad, and we can solve it. July 31st, 7:40 a.m. for Prism. Dude. All right, let's get this going. I am going to go ahead and turn off the tunes, though, however, so sorry about that while we go ahead and do this problem. So I'm going to go ahead and also record so I can break this down. What did you use for the front end of your SpectraSim project? React and Tailwind. It was a great learning lesson with those two. Really liked using those two. Second time with React, first time with Tailwind. All right, let's go ahead and jump on in. All right, hello everybody. I appreciate everybody for being here and joining me today. We are going to be jumping back into MIT's OpenCourseWare, more specifically their 6.0002 Fall 2016 Introduction to Computational Thinking in Data Science course. This is a free course offered by MIT OpenCourseWare online, and I am live streaming it live. So feel free to join me every single day here around 7 p.m. PST on the channel to watch me complete these problem sets and watch lectures and complete courses and etc. Cool. Let's go ahead and jump in. That's a good enough intro for me. So let's go ahead and get into this, yeah? So I already have this downloaded, so let me go ahead and open up a new folder called problem sets. Right, and then let me open up a folder called problem set 1, right? Let me also open a folder called problem set 2. And let me just call them problem sets, like that's fine. Okay, and so let's go ahead and let me open up this. Open up my downloads, this file here. I'm going to take all these files and I'm going to copy them into here. Here we go. All right. Is there a PDF viewer extension in VS Code? 8.5 million is pretty good. All right. Cool. All right, let's jump into this. This will be fun, hopefully. All right, so 6.0002 problem set 1, space cows transportation. 2016. Oh, do Halloween. All right, introduction. A colony of what are those? Ucks? What? Super intelligent alien bioengineers has landed on Earth and has created new species of farm animals. The AX are performing their experiments on Earth and plan on transporting the mutant animals back to their home planet of Arok. In this problem set, you will implement algorithms to figure out how the aliens should shuffle their experimental animals back across space. Ooh, getting started. Download problem set 1.zip from the website. Do not rename the files we provided you with. Change any of the provided helper functions. Change any function/method names or delete provided doc strings. You will keep the ps1 partition.py, ps1 cows data text, and ps1 cow data 2 text in the same folder as psla.py and ps1a.py and ps1b.py. Please please consult the style guide. We will be taking point deductions for specific violations. Ooh. Okay, so you will need to keep the partition py, the data 1 and data 2 in the same folder as so everything just in the same folder. Okay. Part A. Transporting cows across space. The aliens have succeeded in breeding cows that jump over the moon. Now they want to take home their mutant cows. The aliens want to take all chosen cows back, but their spaceships have a weight limit, and they want to minimize the number of trips they have to take across the universe. Somehow, the aliens have developed breeding technology to make cows with only integer weights. Okay, so we have whole integer weights for cows. The data for the cows to be transported is stored in ps1 cow data.txt, and another set of cows for another separate transport are in ps1 cow data2.txt. There are 2 files for you to read from and test individually. All of your code for part A should go into ps1a.py. Okay, let's try it out. Should be fun. ps1 a.py here. Okay, let's try this out. Oh boy. Problem A.1. Hey Charlie, how's it going? First, we need to load the cow data from the data file ps1cowdata.txt. The file ps1cowdata2.txt is given as another file that you can read and test from. We also encourage you to write your own cow list files for testing, but for now, just work with the ps1 cow data. Okay. You can expect the data to be formatted in pairs of XY on each line, where X is the name of the cow and Y is a number indicating how much the cow weighs in tons. Here are the first few lines in ps1 data.txt. So it's just, comma separated values of each cow. Gotcha. You can assume that all the cows have unique names. Okay. Implement a function load cows with a file name in ps1 a.py. It should take the name of the data text as a string, data text file as a string, read its contents, and return a dictionary that maps cow names to their weights. Oh, cool. If you don't remember how to read lines from a file, check out the online Python documentation, which has a chapter on input and output that includes file I/O here. Some functions that might be helpful are stir split, open, file read, close, right? All right, that's pretty easy. What the heck? That's it? No, come on. That was so anticlimactic. Okay, here we go. Your code here. Dun, 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 dun. Here we go, boys. MIT. I thought this was going to be like, I'm not going to speak too early, but I thought this was going to be like tough. Like the CS50 ones. Okay, so we're just going to do a load here from PS1 cow data, right? So we're going to say with open, let's do file name, right? We're going to open it in read mode, and we're going to say new lines, I guess, are just skipped for Windows people, right? Or blank. Then let's go ahead and say as file. Let's give it a variable descriptor. And then we can go ahead and say lines is equal to the file dot read lines. And let's just preview what this file looks like. Okay, so everything's in the same format and there's no header on this file. So let's just read lines, and that'll save all the lines as each line is a list or is a string, right, within a list of lines. So if we go ahead and let's just go ahead and see if we can print lines here and get this to work here. So is there a test problem here? No, I don't think so. So there is no like, okay, that's fine. Let's just run file name is equal to here, and we'll say, what is it, ps1 cow data.txt, and then we'll say we'll run the, what is it called, load cows function, and on the file name, right? So that will we'll see if we get these lines printed out as a list here. Can we do it here? So no such file path as this, okay. PS1 cow data. Are we spelling it right? PS1 underscore cow data.txt. Okay. So I'm gonna go here and get the relative path. And let's put this here. Right, so now we'll get it. Yeah. Okay, so now we got a list of strings, right? And then we are getting, with these read lines, you do get the like, indicators, right? So how do you get rid of those with the read lines? What indicates this \r? Herman doesn't have it here. Lola doesn't have it here. Right. So read the contents of a given file. Assume file contains the data, comma separated, counting, weight pairs, return the dictionary. Let's look at the read lines here. Does this take any additional parameters here? Returns a list of lines from the stream. Hint can be specified to control the number of lines. The hint can be specified to control the number of lines read. And see, it's the hint. Okay. So this just reads all the lines. So then if we want to do this without receiving back the I don't want to I don't want to well, the backslash will be a delimiter, but some of these don't have a backslash. There's got to be a cleaner way. So actually, if I just do line equals to file.read line and just print line here, I just get a line object, right? A text raptor object here. So if I print read until new line or end of read. Interesting. So we call this read line here. Oh, that's why. Just a bug. Okay, guys, so this just actually reads the line. Okay, so if we just say content equals file.read, right? And then do you have to specify anything in the read? No. This will give all the content. We say for line in content, we're going to go line.strip. So we will strip off the end, and then we will split on a character of a comma here. I don't think we can strip actually on a strip, so we'll say line equals, we'll kind of clean the line. Right? And then let's go ahead and see if we're still getting the line. So this goes character by character. Oh, for every character until you reach a delimiter, a new line. Delimiter. Interesting. So if we say print content, rather, it just prints like a paragraph then. Okay. Of characters, basically. Okay, got you. So I have all the contents here. Now, if you say for char in content print the char, this will just print it. Yeah, it just accesses every char. Okay. Then it has to choose. This is the tab for the space. The enter. Okay. Yo, what's up, Mr. Tim? All right, so now if I say read line, now what do I get with content? I need to get better at these file interactions too. Just the first line. Okay. All right. Read lines. So we'd obviously want lines, and then we need to get rid of characters. So we say, I don't want to have to go through every line and also strip out the I don't want to have to also strip out the delimiters in the end, but can you remove the delimiters? Let me look up. File.read lines, remove ending. That'll print you all the lines, right? There, it just shows the characters appended. Use rstrip. But what does the \r do as well? Forgot that one. Not really what I'm looking for here. Read lines. Let's do the \r. The read lines method is used to read all the lines in the file and returns them as lists of strings, where each string represents a single line from the file. Each string is returned list, including each string in the return list includes the new character at the end, new line character at the end, except for the last line. Why does have some? What? Why did some have \r? Right? Let's just go like this. For Right, let's see. Oh, it gives the return. Ah, that's what, okay, I'm so dumb. So dumb, dude. Okay, okay, so we just need to, um, so let's actually print off lines. Let me print content here. So Maggie has a new line. Backslash R, right? Is that the return? No, not raw strings. What does the backslash R do? On every... And why doesn't Herman have it? Doesn't make any sense. Why doesn't Herman... What is the backslash R? Strings. Return character. Oh. Oh, it's a Windows thing. Oh, okay. Okay, so it's like a Windows thing or an old Mac thing. It's just pretty much the same as like the backslash n, like a return character. So it should be handled with the strip method as well, pretty simply, right? So we'll do line.strip. And so what we can just do is we'll just say lines is equal to line for line. Line.strip. Hey Blankers, how's it going? So we'll get all the lines out here, right? And now if we go and print the lines here, this will take care of it. There we go. Sweet. I'll do that one more time for you guys here. Nice. So that backslash R was a like a Windows generated CSV or like an old Linux, it said. So I haven't seen that before in some of these string notations, which is interesting. So the strip method removes those delimiters automatically, and so we were able to just do that, and it took care of it for us as well. So we now have all the lines extracted out. Now we would also, instead of doing 2 loops, let's just go like this. Cows is equal to a dictionary, and we're going to do this. For line in content, we're going to say line equals to line dot strip, and we're going to then say cow, or what you're saying, name and weight is equal to the line dot strip or split on the comma, and then what we're going to do is go cows index of name equals to weight. Equals to weight. So that will assign inside of cows the name as the key and the weight as the value. But what we're going to do is assign the integer of weight, right? Now we're just going to return cows at the end of this loop. So I think if we just go here, oh, we're printing anything, we're just returning, right? Let's go ahead and there we go. Now we have Maggie 3, Herman 7, Betsy 7, Oreo 6, Moo 3, Milkshake 2, Millie 5, Lola 2, Florence 2, Henrietta 9 in the dictionary, with strings as the names and key and values as the integers, the weights. Sweet. All right, let's keep on chugging here. Nice, DJ. That sounds awesome, my guy. That's the same here with me, my friend. Welcome into the stream. I appreciate you joining me here. Okay, let's go back to the PDF here. All right. Problem A2, greedy cow transport. One way of transporting cows is to pick the heaviest cow that will fit onto the spaceship first. This is an example of a greedy algorithm. So if there's only 2 tons of free space on your spaceship with 1 cow that's 3 tons and another that's 1 ton, the 1 ton cow will still get put onto the spaceship. Right, enough to go in but not without going over. Implement a greedy algorithm for transporting the cows back across space in the greedy transport. The result should be a list of lists where implement a greedy algorithm for transporting the cows back across space in greedy cow transport. The result should be a list of lists where each inner list represents a trip and contains the names of the cows taken on that trip. Okay. Okay, so assumptions. The order of the list of the trips does not matter. That is, 1, 2, 3, 4, and 3, 4, 1, 2 are considered equivalent lists of trips. All of the cows are between 0 and 10 tons of weight. All of the cows have unique names. If multiple cows weigh the same amount, break ties arbitrarily. The spaceship has a cargo weight limit in tons, which is passed in the function as a parameter. Example, suppose the spaceship has a weight limit of 10 tons, and the set of cows to transport is Jessie 6, Mabel 3, Callie 2, and Maggie 5. The greedy algorithm will first pick Jessie, the largest cow, for the first trip. There is still 4 tons of space on the trip. Since Maggie will not fit, so we have to exhaust all options, got you. Now there's only 1 ton of space left. Okay, and are these in order? No, they're not. Okay. Now there's only 1 ton of space left, and none of the cows can fit in that space. So the first trip is just Jessie and Mabel. For the second greedy algorithm, the first pick is Mabel, the heaviest cow remaining, and then picks Callie, the last cow. Since they both fit, it makes a second trip. This is what's returned. Okay. That seems cool. Let's try it out. So let's first modify this load cows function to return our list of cows in sorted order. So let's go and return let's return, right? Oh, how can we write this on Lambda really quickly? Think, Mike, think. Return return cows dot sort, and we will sort using a lambda function, and we'll do this by doing for the value input of x, we're going to sort on, come on, think, lambda functions, come on, you got this. Come on. We're going to sort on whatever we're sorting on. Is it cows of x? Oh, I can never remember these lambda functions. Is that it? Did I do it? No. You can't sort a dictionary. You can with Oh, that's right. Okay, I remember now. All right, so what we need to do is we need to call return sorted on the iterable of cows, where our key, right, cows, but we're going to do cows. We need to access the items, right? And then we need to access but it doesn't want us to modify the dictionary. Was that a parameter? Make sure not to mutate the dictionary of cows that is passed in. Oh, so it wants us to sort inside of here. Okay, so let's do that. Let's return cows here. Now we're getting cows here with a limit of 10. So let's first sorted cows is equal to sorted on the cows dot items, right? And then the key is going to be a lambda function where we're going to sort um, on the item, right, rather than the key. Yeah, on the item. But I don't want to sort. But what about if it's like based on value? So then if we print sorted cows here, this loads cows. We have cows here. We have um, greedy cow transfer on cows, right? So I run this. Print greedy cow. To that's not in sorted order. Um, leverage Python, shave until 3K subs. Okay. Okay, so greedy transport. So we have sorted cows equals the sorted of cows dot items is the iterable. And the key is equal to lambda, right? Item. I don't think that's right. X1. So let me what is item index of 1? Huh. By item. So that's, can you sort them just off of, terrible at these. Sorting my data item 1. Then if it's like item 1 reverse equals true, a certain descending order. Okay, so now what I can do is say is a greedy algorithm though always pick the heaviest cow that will fit onto the spaceship first. This is an example of a greedy algorithm. So we sort and pick the heaviest until we don't have room and then make a trip. Yep, so we got you. Okay, so we'll do sorted cows is equal to a sorted dictionary of every cow's items, right? Where the key is the item where we sort on the, the value, and we set the reverse to true to get the the heaviest cow up first. So what I can do now is I can say for name and weight in sorted cows dot items, we're going to say if weight is less than or equal to if the current limit minus the weight is less than or equal to 0, no, sorry, greater than or equal to 0, right? Then we're going to, this is an acceptable cow. So we're going to say, well, first off, we're going to have trips is equal to a list. And then we're going to say, while while sorted cows, right, we're going to take a trip is equal to an empty list. And then we're going to say for name, weight, and sorted cows dot items, if the limit minus the weight is positive, meaning that we can put this cow on board, what we're going to do is we're going to trip dot append the name of the cow, and then we're going to go ahead and so the thing is each cow has a unique name as well. So I'll say taken, right, is equal to an empty set. And we'll say taken dot add the name, right? And but we'll say if this, right, and name not in taken, then we're going to go ahead and append and add to taken the name and to trip, right? So then we can pass over it the next time rather than deleting cows out of the dictionary. I don't think that that's the best way to do it because then we lose like our iteration place. Right, so we have trips, and so we're saying for every name, if the limit minus the weight is greater than or equal to 0, and the name is not in the taken set, then we're going to add the name of the cow to the trip, the current trip, and to the taken set overall, right? So then, now what happens if it's not, right? So then we're going to just pass over this cow, right, and move on out of the loop. And then, so what we're going to do is at the end of this loop, we're going to say trips dot append the trip, right? And then that will add it to the trip at the end of each loop through the cows, right? While we have sorted cows. Now here's the thing. While the length of sorted cows dot keys, right, is greater than the length of taken, we'll do this loop, right? So the length of the keys, so the total number of cows we have, as we increase taken, right? Once taken becomes equal to the length, we've taken all of the cows available, and we'll stop this loop, and then we will return trips. No? Right? So let's see if this print will work here. Betsy, Henrietta, Herman. So, okay, so the thing is, we forgot one step. We forgot one thing, is we need to decrement limit let's set, we need to, actually, so this goes by limit, right? So while we take as many cows as we can in the limit, so while limit is greater than 0 and the length right, and so then we'll just decrease the limit by 1 after we take a cow. Oh, dang it. So while the limit is greater than 0, we're going to decrease the limit here. But we didn't take anything. Oh, sorry, not by 1. by the weight. I don't think that's going to solve our loop issue here. So for every name, if the limit is minus the weight is greater than or equal to 0, and the name of the cow isn't already taken. Oh no, limit is a weight limit for the spaceship, an integer. Yeah. So limit goes down by weight. The length of sorted cows is greater. Is greater than the length of the taken set. Right, we're going to loop over all, create a trip. We enter into this loop, but we never break out of it. So let's see here. We say if else so no matter what, it's appending the trip. So else continue. I mean, it already will be happening. No matter what, right? So we don't even really need it. I don't think so. If the limit, then we append the name and add the name to the taken set. We then decrease the limit by the weight, and then we continue looping over cows for more cows. no, we would break out of this for loop and enter back into here. So we would break out of the for loop because we found a cow that was valid. So let's go like this. Okay, so while the limit is greater than 0 and the length of the sorted cows.keys is greater than the length of the taken set, we're going to create a trip. So maybe let's just do this. Let's just say while the limit is greater than 0, and no, because I don't want to delete stuff out of this. I don't want to modify this, right? So while the limit is greater than 0, we're going to continually search for cows. And there are, right, and it has to be in the length of sorted cows dot keys, right, greater than, now do we want to do it on the last cow? No, because that means we would already have taken all the cows. The length of the taken cows. We're going to continually loop for cows. We're going to create a trip. We're going to find a cow. We're going to decrement the weight limit. We're going to break out of this loop. This appends. So we don't want to append the trip right away. This is from MIT. We got a snack pack here. Gonna have some brain food here. Let's keep on rolling, you guys. Let's keep on trucking. This is MIT 6.0002. Computational thinking and something else. Okay. So we sort the cows. So then how can I see while the limit and while we have cows to choose from? That's my thinking here, right? While we have available space and we have cows left to pick. Oh, per trip. So then we need a reset limit. Okay, hold on. So while the length of cows available to pick from, right, we're going to take all the cows, right? The limit just depends on per trip. So we have to say while So else, so if limit, right, and if the limit is, okay, if the limit, okay, else, if name isn't in taken, right, else we'll just, if the name is in taken, we're going to just continue. Right, and then on this guy, if the limit minus weight is greater than 0, we're going to go into this. Else, if it's not, meaning that so we want to add cows until we can't add cows anymore, right? So we're going to have to look through all the cows no matter what. So no matter what, we're going to have to look through all the cows, right? So it's going to be, okay, interesting, okay. I don't know why this is so much more. I spoke too soon, you guys. Oh my gosh, I feel like an idiot now. Okay. That's the stupidest thing I've ever heard, brain. Okay. For name, weight, and sorted cows dot items, if the limit minus the weight is greater than or equal to 0, we're going to take the cow if it's not already taken. How's it going, random? We got a lot of people in here. Appreciate you guys joining me here. Okay, so let's focus up here. Focus, full focus, full focus. Okay, so for every name and weight and sorted cows item, we're looping through the cows. If the cow that we're on can be taken, we're gonna take it, right? So we are gonna take, so if it is in the taken, we're gonna pass, right? Else we're gonna continue over this guy because we don't want it, right? Now, if the weight limit of this cow if this cow would be the limiting, the cow would stop here, meaning that now we can't add it. This cow would go over our limit, right? We're going to trips we're going to break out of the loop and we're going to add the trips to the trip to the trips, right? So if the weight limit ever becomes, exceeded, then we're going to break out of searching for cows and we're going to append the current trip, right? And then we're going to go back in while we have cows to still search for or still take, and we're going to keep going here. Let's try this. No. Where is this loop error? Sorted cows.keys. Okay, it's just empty the whole time. Not even going into here. Sorted cows.items. So trips never gets appended here. Okay, so why do I suck? We can't modify the dictionary, so we have to track what cows we've already seen by their unique key. Right? So let me add Betsy. He is now 9. Okay, now Henrietta with the weight limit of 9. We break. We pen Betsy. Print trips Betsy. Oh, okay, because I'm not resetting trips back to 10. Or limit, right? That's why. Cool. I think we figured it out. Okay, so the limit of this, right? So limit here, limit copy equals to limit, right? We need to keep a reference of the limit copy, so we can say that limit becomes equal to limit copy. So we reset it back. Right, so now we're getting so now what I'll do is I'll just remove this print here. And there we go. So we take Betsy, then we take Henrietta, then we take Herman, then we take Oreo. So let me go ahead and print sorted cows, right? As well. So Betsy, Henrietta, Herman, Oreo, Millie. So we can't stack anybody until we get to Maggie. Maggie and Moo and Milkshake, 368, and Lola we can stack. 3, 6, 8, 10. Oh, sorry. So 9, Betsy its own, Henrietta is its own, Herman is its own, Oreo is its own, Millie and Maggie are together at 8, Moo Milkshake 5, 7, and 9 with, okay, yeah, I think we solved it. All right, this is my answer. Long, and that took us long enough. Jeez, spoke too soon. Spoke too soon. Those that are new here, my name is Michael. 26 years old. I got a degree in human biology and a minor in chemistry. And I work as a formulation chemist for a biotech company where I manufacture biological controls from scratch that are used in like patient diagnostics primarily, research and development, and like advanced analytical testing. I've been doing that ever since I graduated back in 2021. I've been teaching myself how to code for a little over a year now, streaming almost every single day here on this channel. So if you're new here, thanks for joining me here. Let me know what's up with you in chat, and let me know how your learning's going. I appreciate you guys all being here. Welcome. 2 subs away from 2.7. We're going to shave the beard. I'll shave the beard at 2.7. I'll come back no beard tomorrow. Okay. So, I think this is our answer. Right, I think this is our answer. This is MIT's problem set 1 from their 6.0002 course on OpenCourseWare MIT. We just completed 8.2 greedy cow transport. How do we check? Like, is there a way to check? Find out. Brute force cow transport, problem A3. Another way to transport the cows is to look at every possible combination of trips and pick the best one. This is an example of a brute force algorithm. I think I'm gonna stop my recording on Twitch. It's been too long, or on YouTube, or just my recording in general. I don't think I'm gonna upload the problem sets to the channel. Kind of changed my mind. They're gonna be way too hard to chop and edit. I'm just gonna link reference to the full live stream, or the live streams like I did in the past. Sorry if I missed your chats. Please let me know, and I'll go find them. I'm sorry if I missed everybody's chat. Charlie, speaking of Zuck, yeah, dude. Speaking of Zuck, do you guys see Meta's like S tier earnings report balance sheet today? Jesus, dude. You know, let me tell you guys. I've been saying for a couple of weeks now that Meta's gonna be a $800 plus, $1,000+ stock here. Probably split off maybe before then, but I don't know. They just posted a phenomenal earnings report, and but their options and their stuff is just so expensive, man, and it's inflated. It's just risky because one wrong move, but it's just a strong company though, so you don't really think it's really ever they're not going to have a wrong move, but you never know. So it's hard to get in there. Pause. Another way to transport the cows is to look at every possible combination of trips and pick the best one. This is an example of a brute force algorithm. Implement a brute force algorithm to find the minimum number of trips needed to take all the cows across the universe in brute force cow.transport. The result should be a list of lists where each inner list represents a trip that contains the names of the cows taken. Make sure not to mutate your dictionary of cows. In order to enumerate all possible combinations of trips, you want to work with a set of partitions. We have provided you with a helper function called getPartitions that generates all the set partitions for a set of cows. More details on this functions are provided below. Assumptions. Again, you can assume that order doesn't matter. 1, 2, 3, 4, and 3, 4, 1, 2 are considered equivalent lists of trips. And 1, 2, 3, 4 and 2, 1, 3, 4 are considered the same partitions of 1, 2, 3, 4. You can assume that all the cows are between 0 and 10 tons in weight. All the cows have unique names. If multiple cows weigh the same, break ties arbitrarily. The spaceship has a cargo weight limit in tons, which is passed into the function as a parameter. Helper function, get partitions. To generate all the possibilities for the brute force method, you will want to work with a set partitions. For instance, all the possible two partitions of the list 1, 2, 3, 4 are 1, 2, 3, 4, 1, 3, 2, 4, 2, 3, 1, 4, and 1, 2, 3, 4, 2, 2, 3, 1, 3, 4, 3, 1, 2, 4, 4, 1, 2, 3. This will help you with creating partitions. We have included a helper function, getPartitions that takes as input a list and returns a generator that contains all the possible partitions of this list from 0 partitions to n partitions, where n is the length of the list. To use generators, you must iterate over the generator to retrieve the elements. You cannot index into a generator. For instance, the recommended way to call getPartitions on a list of 1, 2, 3 is for partitions in getPartitions of 1, 2, 3, print partition. Try out the snippet of code. Okay, I'm not going to get ahead of myself here, but I think I know how to solve this one just by reading through the problem. If it's getting the partitions for us, meaning we don't have to recursively gather all of the possible combinations, we can just we can loop through our generator, compute a comparison across each trip to make sure each trip doesn't go past our weight limit. And if it doesn't, we're going to add it to a set, and then, or add it to like a verified set, and then we're going to take the minimum length, the value with the minimum length, right? Or we could just probably do that right away. So let's go ahead and try that out here. So we have this partitions.py get partitions function. So I'm going to say for partish, or we'll say for every, what are, so the partitions are each one is considered a trip, right? Yeah, so for trip in get partitions on the cows list, so we'd have to have a cows well, the thing is actually we have to map. Oh, shoot. Oh, okay, let's do this. Let's do this. Let's build a partition of cows based on the name, and then let's map the values of every cow's value to that partition map. So what I mean by that is for trip and get partition on the cows, we're going to have to do it on cows.keys, right? This will go over. Now what I'm going to do is I'm also going to take this sorted here. I'm going to sort the cows. Right? I'm going to sort the cows. Well, actually, that doesn't matter. I don't need to sort the cows because I'm going to just map them from their keys to their values anyways. So for trip and get partition, so each partition is a trip, right? Now we need to validate the trip. So let's say if the length of the trip, oh no, so we need to map the trip. So we'll say mapped is equal to we'll say trip weight. Trip weights, right, is equal to a list where we say so this is going to give the name this is going to return back a generator all the. So we would have to cows.keys. We're gonna get partitions of all of the possible combinations of the cow names, right? And then we're gonna map the trip, right? This is the partition with all the names in it. So we're gonna say for trip weights equals to this. For name in trip, right? We're going to go into the cow's index of that name, get the value, and add it to trip.append here. So what we can do is do cow's index of name for name in trip, and then get rid of this. So that'll give us all the trip weights, and then we'll validate the trip weight, right? So we need to make sure the trip weight doesn't go over our limit. So if trip weight so if sum of trip weights is less than or equal to the limit, then we're going to, so if let's first handle, let's do the if it's greater than the limit, right? We're going to continue, right? We're going to continue past this partition. This trip is not valid. Okay, so it is valid now below this continue statement. So if the trip is valid by weight, right, we would want to add the trip so what else makes a trip valid? Just the weight. If it's a valid trip, we're going to say trips. Else, we're going to say trips.append trip because it's a valid trip. Now, what if I just make trip a set? And then I go trips.add trip.sort. Okay, so what am I doing here? I am creating a trips set so I can get all unique. I don't get duplicates, right? I'm not going to get duplicate partitions, right? Of just different, combinations or whatever, in different order, right? So a list. Oh, hold on. I think I'm doing this wrong. Oh, no. Come on. Hold on. So the list is 1, 2, 3, 4. All the possible 2 partitions of this list are, so just 2 lists separated. So if I say, let me take what it has here, this code snippet, and try it here. Let me run brute force cows. So let's go to okay, so it's going to give me all the partitions of the names. It's going to generate me. So the first one's going to give me this one, and then this one, and then this one, and then this one, and this one. Okay, so it'd be like this. It'd be 4 partitions in get partitions of cows.keys. Right? We're going to print, want to print the partition at the start here. So now all the possible combinations of names together, right? So now if I say for trip in trips, no, for trip in partition, right? For partition and get partitions, right? And then for every trip in that partition, let's just print the trip here. Let's not print the partition. A bunch of inputs. There we go. Now we're going to print trips here. None. If this trip waits, be a valid trip. So the trip weights. So if the sum of the trip weights is greater than the limit, then we're going to continue looking for a trip that's valid. Now, if we find one that is valid, we're going to add the trip sorted trip. Unhashable type list. Type error. Oh, I can't add a list to a set. Unhashable type list. So I can't add. I can't add these to a set, can I? That's right. It wants a list of lists, though. I don't want to have to convert to a tuple. Right, I have to like tuple the sorted list. So Herman milkshake is a valid combo. Do we have any duplicates? Well, no, it's a set of stuff. So these are all the possible combinations. Is there any way to test this? Is this right? So is this a valid brute force algorithm for this problem? They don't have any like key or anything for us to look at, I don't think. Suppose it first tries Jesse, Maggie, Mabel, Callie. This solution will be rejected because Jesse and Maggie together over the weight limit cannot be on the same trip. So, if we were wanting to find the allocation of cows that minimize the number of spaceship trips via brute force, this brute force should follow. Enumerate all the possible ways count divided by trips using the get parameters function. Select the allocation that minimizes the number of trips without making any trip that does not obey the weight limit. Okay, so we instead returns a list of lists. Okay, so what we would have to do then, cheese break, is we have a list of lists. We need to validate the entire trip. So for every trip in partition, if it, then we're gonna break out of here, right? Right. Now, if you get to okay. So for trip in partitions, we need to identify if this trip is valid, right? So in order to do that, it has to have the partition has to be, in order for the partition to be valid, every trip within the partition has to obey the weight rule. So we're going to have to say best is equal to what? Like none? Or we'll say like best trip. So then we'll say for trip in partitions, if the sum of cow for trip in partitions. So sum cows index cow or cow index name for a name in cows.keys right in this trip. So for every trip in the partition, we're going to sum the the value of the cow's name for every name in the trip. So each trip, the trip is an iterable itself as a list. So the trip has a list of names, be the cow's keys. So we're going to get the value in some. So if this is greater than the limit, meaning we're over, we're going to break, right? You guys agree? Sorry, I'm missing chats here. How do you deal with constant comparison with others? I constantly do this and it's demoralizing. Hey, Star. I appreciate your transparent comment. That's very genuine. Honestly, dude, honestly, the best and honestly the simplest advice I can probably give regarding lack of comparison is that it's bound to happen. So when it does happen, don't beat yourself up because it's a natural human instinct. It's like a survival instinct of compare to survive, right? Um, Also, without comparison, there would be no growth. You wouldn't not know what there is to obtain or what goals you could obtain without comparing your current skills. But where it starts to go bad is when you let it affect your self-esteem, right? So now, if you're talking about like in terms of like, there's two ways I'm thinking about this, like in comparison from like an embarrassment standpoint, maybe like not being like able, not like like an interview or something, like if you don't do well. How I do that is like, that's probably not what you're talking about, but I'll talk about the other point is to solve that issue is what I like to do is I just completely think to myself, I'm never going to see these people again in my life. And if I do, great, who cares? But 99.9% of the time, I'm never going to see that person again. So, like, there's no point in like being embarrassed or something. But if you're talking about comparisons, so I don't know why I brought that up. If you're talking about comparisons for like in terms of like skill and let's say like you watch the channel and you're a new programmer and you're saying, oh, Mike seems to be programming. What's he doing? I can't really do this right now. I've only been doing this for like a year, and it's been honestly, it's really just. They say it's not linear to the amount of time you put in, but a lot of programming at the very start is just showing up, um, and giving at least giving an effort. If you show up and give an effort, and at least like a decent human one, I think you'll be able to learn and pick up quite a lot. But you know, I think the best advice, to know is that it is natural to do those things. And so you have to learn not to beat yourself up when they happen, but to flip the script and view it as an opportunity to, gain, right? Maybe. um, I have the same issue. Sometimes it helps you just ask questions to see if you can do it yourself, and if you can't, try breaking it down. Also, repetition on your skills while hone on it. Hone it. Nocturnal Void. Hey, I just joined the live and got me spit my drink out. Choose chips loudly. What? I was chewing chips loud. My bad. Seems pretty brute force to me. You can use the tuples to handle the uniqueness and then convert back to a list of lists if you need to end with that. That's a good idea, Quinn. MIT 60002 is just a reference sheet PDF to help with understanding the language. It's just this is like a problem set. It's like a homework assignment. Hey, Leonardo. Thanks for the follow on Twitch, whoever that was. Hey, we're at 2707, Mr. Tim. Appreciate you guys being here so much. Let's go ahead and get some tunes going because I'm not recording anymore. So we can have some background tunes playing. I'm probably going to finish this problem and then call it for today and come back and finish the rest of the assignment tomorrow. There's no rush. Okay, so let's finish this guy.
Tim says, YouTube is wiping Twitch gang rip bozos.
Rip bozos. So print. So we're going to sum, right? And if it's over the limit, we're going to break out of this. I'm going to set. I'm going to break out of this loop over all the trips in the partition. So we need an indicator to say, okay, this is a valid partition. So we have to say like valid
Quinn says,
equals
also,
to
want to continue, not break unless I'm misunderstanding.
Valid equals to true by default. We're going to set valid equal to false here.
Seeing you voluntarily doing homework XD.
People are going to go feral seeing you voluntary. Dude, that's a very honest take, and it's pretty accurate. People get, I don't know, people, they don't really get like upset, but I do find that the internet, it does amplify that kind of know-it-all mentality, especially when people are trying to like learn something new. I do get a lot of the know-it-all, you know. You can definitely, weed those people out quick though, because when you start asking them questions, you don't really get very good answers back. When the people that actually know what they're talking about, that respond, that help, they actually do help. So it's pretty easy to weed them out, but it's funny. Okay, so for partitions, we're going to say for trip and partitions, if we sum, we're going to set that this is valid, and we're going to break out of looping over this trip because we don't need to continue over these trips, right? Because we found a trip that's invalid, and this partition now is not valid. So if I then say if valid,
Nocturnal Void says, how will one learn something without challenging themselves with something they would not know?
Exactly. So if valid, right, if that is a valid partition, meaning that we never hit this case, then what we're going to do is we're going to say if best, so if not best becomes the partition, right? If there is a best, right, else, right? If there is a best, we're going to take the length. We're going to take if the length right, the number of trips, if the length of best is greater than the length of this partition, then we're going to override best to equal the partition. Okay, so we're looping over all the partitions, which is every possible combination, basically, which is every possible, combination of trips to make, right? So we're going to loop through all the partition combinations of trips and evaluate each trip in the partitions. Right? If the sum of the trip is greater than the limit, we're going to break out of this because we don't need to continue evaluating trips in this partition because this trip, one of the trips, doesn't meet the standard. If it is valid, right, we're going to say if there's not a best already there, we're going to say best is equal to partition. Else, if there is a best, we're going to determine if the best should be overridden by the partition. And then, if valid, And so then do we just a list of lists? So do we just return best here? What do you guys think? Right? What do you guys think? So we run this. Let's try it. Okay, so now let's go and let's print best. Boom. So here's the best combination of trips to make. You take Henrietta, then you take Maggie, Millie, and Florence. Then you take Herman and Moo. Then you take Lola, Milkshake, and Oreo. And then you take Betsy. Which makes sense because this is a 9. This is a 9. This is a 5 and a 3. These ones are small and these ones are small. What do you guys think? Is there like, I don't like how there's no key. Like with CS50, you could do the check 50 and at least see if you were correct. List of lists. Yes, we do.
Nocturnal Void says ONVM.
Yeah, I started with Python, and I've taught myself a little bit of like React, Tailwind, JavaScript, a little bit of C with the Harvard CS50. But I mainly am just gravitating back towards Python because I do have, background in, biology and chemistry, and I am a scientist. So I do, it would be useful to have a lot of these things. So I've been teaching myself for a little over a year now. We've come quite a far way. I built some pretty cool projects. You can check out all my projects at michaeldeming.com. Give you guys a little preview here. I got my projects here. You can go to like SpectroSim, which is a pretty cool project we got right now, live on the web, where you can like search up compounds from PubChem database, and then on my front end within my full stack project here, it's hosted with render.com, so it's pretty slow for the initial search on the spin up time of the server, but it'll auto populate and create the absorption spectroscopy, which is a kind of experiment that you do in your undergrad, which is pretty cool. So I'll let that load here, but yeah, we'll let that load. You can check out more of my projects on michaeldeming.com. We built these live on stream here, completely, transparently on stream. But yeah, that spin up time on the server is brutal for render.com. Let me tell you, dude, it's still not even up. Makes it look like it's not even working. But it's working, let me tell you.
Nocturnal Void says, yo, I'm curious. Have you ever seen those vids with high barkeepers using flames for a performance effect? What type of chemicals were used for that?
It's usually just alcohol and stuff. A fast burn is relatively not too dangerous. It's not like a lingering. It's usually just alcohol. like a diluted alcohol. There you go. So you can see it has a peak here around 275 nanometers, or which is pretty cool. You can do like other things like caffeine. And this will generate, right? You can see that it has some peaks around 274, 230, 223, 239. Right? And you can access any compound in PubChem. We're scraping its API, which is pretty cool. Okay, let's get back to this real quick.
Nocturnal Void says, I was personally wanting to make the chemical to put on my hands and light it on fire to see how long I can keep it on fire until it starts to burn.
Chill. Bro's trying to be edgy. Alright, let's see. There is no key for this, so there is no key for the problem set. So am I doing this correctly? Your implementation is correct and aligned with problem set 3 is asking you to do. What problem 3 is asking you to do. Try every possible way to group cows into trips. Use the get partitions. Discard any partitions where at least one trip exceeds the weight limit. You check each trip and sum, right? Among the valid partitions, return the one with the fewest trips. You track and update the best one only if the current partition uses the fewest trips.
Nocturnal Void says it's cool, alright. I already made a flamethrower for my wrist. I want to experiment a bit.
So if valid, if best is none, or but what if best is not none? Oh, or. Oh, either or. So if it's or, then best becomes partition. Okay, yeah. So it can be if best is none or this will also work and make it just that. Yeah. Okay. I think that solves this one. So what we do is we loop over all the possible trip combinations. We go over each trip and each trip combination. Once we find a trip that doesn't fit the mold, we break out of that trip combination because we don't need to continue further iterating over that invalid trip combination. If at the end of that trip combination, if it turns out to be a valid trip combination, meaning we never hit this flag, then we will detect if it is our best combo so far. If it is, we're going to return that one. Cool, I think that does that one. Okay, I think we can probably finish this problem A today. Okay, A4. Implement compare cow transport algorithms. Load the cow data and then run your greedy and brute force transport algorithms on the data to find the maximum number of trips you found by each algorithm and how long each method takes. Use the default weight limits of 10 for both algorithms. Make sure you've tested both your greedy and brute force algorithms before you've implemented this. You can measure the time of a code block to execute using the time.time function as follows. Hey.
Debugging says, how you liking Python, man?
Hey, dude. It's going good. I'm enjoying myself here. We stream every single day, teaching ourselves. We got about 30 people in here, so woo! Thank you guys so much for being here. My name is Michael. I have a degree in human bio and a minor in chemistry, and I work as a formulation chemist. I've been teaching myself Python from scratch, mathematics, and computer science, completely independently with various resources online for free. So also, if you guys are here and want to join my Discord, please do so. It's down below, completely for free. It's like a roadmap of all my learning journey and resources, books, PDFs, courses, personal notes, some stock tips, some hints I throw in there every once in a while. So thank you guys so much for joining me there. And if you guys also, we do like community projects if you want to participate in any of my projects. But if you guys aren't subscribed, please subscribe. I really appreciate you guys being here, and thank you guys so much for pushing us over 2,700 subs today. You guys are awesome. Okay, so let's go ahead and do this. So I think our time is already implemented here, yep. So we want to just say return best. So let's go ahead and say greedy start equals to time.time. We're going to do greedy. We're going to do load cows, greedy start, and then we're going to do greedy end. We're going to put some code in here of the greedy transport, and then we're going to copy this down and do brute start and brute end. And then we're going to do the brute force cow transport at this point in time. And I'm going to take my file name as well and put that here. So what I'm going to do then is I'm going to print a statement where I'm going to put in greedy, and I'm going to put in the greedy delta, and then we're going to do a \n, and then I'm going to do brute, and then I'm going to do brute end, brute start.
Manish says, hey, what course material are you using?
This is the MIT 6.0002 in OpenCourseWare. I didn't put it in the description. I apologize, but it's really easy to find. Just go search up MIT OpenCourseWare online, and it's the 6.0002 course. The first semester course of this section is like fairly kind of similar to the Harvard CS50P, very kind of intro and beginner. I think it probably does move a little bit faster and probably dive a little bit deeper than CS50P does. So I decided to skip that one as our skills are kind of above that. We've already built plenty of projects on our own in that beginner intermediate level of Python, and kind of getting into more advanced stuff. As you know, in our current projects, we're currently developing and writing a project from scratch right now. We did like the SpectroSim, which was the spectroscopy simulator. We did chromatography simulations, and we're also now diving into quantitative analysis with some stock. So I have a really high passion for stock and options and analysis and stuff. So we implemented a Black-Scholes model, which is like a calculus function to determine a value in Black-Scholes point of view of an option contract, given a certain some certain criteria. And so we're going to develop kind of a dashboard. I think would be kind of cool to evaluate kind of options contracts and potentially give them like a weighted value of rank. So I could give it, okay, if the Black-Scholes value, I could give each of these indicators, Black-Scholes, volume, liquidity values, I could give each of these indicators certain weights, and then formulate that into a weighted average to give you kind of like a value, in my point of view, like a Michael Deming's model of this option, and if it's valuable or not. I think that could be a pretty cool, a cross-reference off of many different indicators, giving, custom weights to each indicator, so I could, formulate a total value in my point of view of an option contract, and I can make a decision whether or not I should trade based on that. So that's currently what we're doing on these off days that we're not working on our courses. But yeah, so if you guys are interested in seeing me code that, I did a lot of work on that yesterday, so go check out that stream. I stream pretty much almost every single day when I'm not sick like I was last week. Bruh. Okay, let's go ahead and run this. Let's see what we get. Oh, I'm not running my function here. So we need to run compare transport algorithms, and we need to that's all we need to do. There we go. So as you can see, the greedy algorithm is a lot faster than the brute force algorithm. So I can do like a percent change. Like we could even compute like a percent change. So let's print like, let's save these as variables. So let's do like a greedy delta is equal to this here, right? And then we can do a brute delta is equal to this, and then we can easily just throw in the greedy delta here and the brute delta here. And then what we can do is print a percent change between these two of, what do we want to have like our start be? Let's have our brute algorithm be the change, right? Because it's going to be an increase, a positive percent change, right? So let's go ahead and do the brute delta. So we're going to print out the brute delta less than the greedy delta, and then we're going to divide this difference by the greedy delta, and that'll just give us the percent change from the brute delta to the greedy delta, I believe. And then what we'll do is greedy brute minus this. Yeah, and then what you do is you would multiply this by 100, right? And so that would give you is it really 1,000,000 times faster? 1.5 million times faster? We have 5 orders of magnitude to the left that this is a smaller number for the greedy algorithm. Right? Let's go ahead and I'm going to take this value here. I'm going to throw it into my orb. You got no idea. Oh, come on, stop doing that. Control-C. Throw in the orb here. Is this percent change correct? That's what they're doing. Should be at 1.546, 241.76%. Well, they have 15 mil. Huh. Isn't this working? Root delta. So you could say like percent slower equals to this, right? But then I don't know. How do you? And you could say print percent slower. Maybe the same number. Get it? Why is it correct? Is this correct? It's not really telling me anything. Is this correct? So the greedy delta is extremely fast, whereas the brute delta is pretty slow at 1.88, 0.188, which is 1.566. So it's a 1,000,000% difference. Concatenate these. Concatenate. Induster. How can you
Dig
do
says,
this?
hi, what level is this course? Beginner friendly?
Yeah, it's pretty it's pretty friendly in the fact that sorry, hold on. Yeah, so this is a 2-semester course. The first semester, 6.0001, is kind of more intro Python, like how to use Python and learn it, and then dive into some more like intermediate level things. And then this back half is more about like algorithms and data structures and more kind of in-depth, advanced, more stuff of Python. So I thought this one was better suited towards our current level. I skipped the first one as we've kind of already done that with Harvard CS50P, CS50X, our current projects, Python crash course, DSA in Python, Fluent Python. We've kind of already surpassed those beginnings, right? So let me take this and see if this number is right. $1.77 million% slower.
Dig says, oh, I think I've seen the book for this course at a local library. Reed says, have you considered an online master's degree, like Georgia Tech's OMSCS?
Yeah, hey Reed, thanks so much for that question, dude. I've considered some, master's degrees, but dude, honestly, like, given the current job market, like, I don't know. I think we're coming to like a paradigm or like a dynamic shift in the current education system and market to where degrees really aren't holding a lot of value, especially now, especially at like more like advanced technicalities and levels. Like obviously degrees for like things like medicals or certain types of like licensing will always be required, like for FDA regulations and things like that. But you're seeing kind of like the barrier to entry sort of lower and lower more. And honestly, the payout for the time and cost invested into obtaining certification for these master's programs, honestly, is not, in my opinion, worth it. Now, of course, there are, it can be worth it in your opinion if it's just like it can be definitely worth it for the education. But in terms of just like a time value of life, right? You have to also think about like life, like you don't have so much time of life too, like a time value of life, money, and then return. Now, I say this in the idea that I have found that I've been able to teach myself a lot of what current collegiate computer scientists are learning, and I not like super advanced things like in the masters and not none of that, but like CS majors. Like I've been able to kind of teach myself through the first 1 or 2, almost like 3 years of kind of no, there's a lot more to it, right? There's a more math courses, so like at least in terms of like core like programming classes, like I've been able to teach myself a good chunk for free. So I'm really kind of, I don't know, I'm really tossing up the cons of it. I will be honest and say I have considered it, but I really don't feel that it would be super beneficial. Now, if I was going to go back for a degree, it definitely probably wouldn't be online. I'd probably go back in person to build connections in that industry and everything. And then, and it would definitely be in computer science. It wouldn't be in chemistry or biology. But I don't know. What do you guys think? What is your guys' take on master's programs in computer science in general? Okay, so that was A4, comparing the cal transport algorithm. So make sure you tested both your greedy and brute force algorithms. You can measure this. This will print the duration seconds as a float using the given default weight in the 10. And the cal in both algorithms, you should not take more than a few seconds to run. Answer the following questions in a PDF file called ps1answers.pdf. Okay, let's go ahead and type these out. I'm going to do them in a markdown. Okay. All right. Let's take this.
Quilt says, I don't have any degree and I'm a DevOps engineer.
Yeah. See, it's kind of interesting, huh? Okay. My results for the compare cal transport algorithms are as follow. And I'm going to run this.
Paul says, I think a degree would help for government jobs, but probably not much else. Quilt says, started on help desk and learned PowerShell to automate stuff, which is how I got into coding, and it grew from there.
Okay. Which algorithm runs faster and why? The greedy algorithm runs faster because it selectively chooses options rather than exhausting all possible scenarios up front. The greedy algorithm runs faster because it selectively chooses options based on predetermined conditions greedily rather than exhausting all possible scenarios up front, then meeting said conditions. Anybody have a better explanation? All right, let's take this answer and let's throw it in here and get some feedback. Can you give me some feedback on my answer for problem this problem? Your answer is on the right track and demonstrates a good intuitive understanding of why the greedy algorithm is faster. Here's some constructive feedback and a revised version to make it cleaner and more precise. You gave a specific runtimes from your own code. You correctly identified the greedy algorithm is faster. You mentioned that the brute force check all possibilities, which is the core issue. Is a bit vague than being used in ambiguous terminology. Use more formal terms like combinatorial, explosive, time complexity, or exponential growth for brute force. So we'll say performance difference. I like that. We'll say about. So it says, the greedy algorithm runs significantly faster because it uses a heuristic approach. It chooses the heaviest available cow that fits in the current trip without considering future choices. This result is a time-efficient solution, though not always optimal. In contrast, the brute force algorithm explores every possible partition of cows into trips to find the optimal solution. This leads to exponential time complexity, especially as the number of cows increases. The combinatorial nature of the problem makes brute force infeasible for larger data sets. That's a good way of saying it. So let's rephrase this into our own words here. So the greedy algorithm runs faster because it selectively chooses cows based on the max weight available within the constraints of the weight limits. The brute force algorithm exhausts all possible scenarios up front, then meets exponentially growing in proportion to the input size or number of cows. Let's see if it likes that explanation. How is this revision? Improvement, clear, concise. The gradient algorithm runs faster because it selects cows based on the maximum available weight that fits within the weight limit without considering future consequences. In contrast, brute force algorithm examines all possible combinations of trips, which grows exponentially with the number of cows. This results in significantly longer runtimes and increases in input size. Selects. So the greedy algorithm runs faster because it chooses cows based on the max weight available within the bounds of the available weight limit. The brute force algorithm exhausts all possible scenarios up front, exponentially growing in proportion to the input size or number of cows. Okay. Does the greedy algorithm return the optimal solution? Why or why not? The greedy algorithm does not return the optimal solution, as it does not take into account any future outcomes or possibility or cascading effects. It only evaluates the input at face value on each pass. The solution could be an optimal one, but could also have room for improvement depending on the I don't really like this explanation that well, but let's go ahead and get some feedback. How about this? Your answer is on the right track. The greedy algorithm does not always return the optimal solution because it makes locally optimal choices at each step without considering the global outcome. It selects the heaviest cow that fits on each trip, but this strategy can lead to suboptimal groupings. While it may also sometimes find the best solution, there is no guarantee it will. So we did say it right then. Does not return the optimal solution, as it does not always return the optimal solution, as it does not take into account any future outcomes or cascading impact. Hey, Quinn, how's it going? I'm a biologist and I learned Python over the past few years. Good luck. Yeah, I kind of use it as like a TA, kind of in the same way. It never would really tell me answers. I would never go to it up front to get the answer first, unless I was being exposed to a topic for the first time and needed some introduction. But I will first try things on my own, attempt things, and then go to the AI tools that are here now to to solidify, to improve upon, or to gain additional insight on my my first thinking. And I found that that's pretty drastically improved my speed at which I'm able to process information and retain it, because I'm having verbal conversations as if I were with another human being, or in a lecture. So it's like, rather than just keeping the information internalized, it's like coming out and then, being discussed in like a conversational way. And so it's been really quite fascinating to see how fast I've been able to actually learn compared to like how much effort I had to put in like college for stuff like this, right? For like biology and chemistry.
Quinogene 87 says 100% I do the same. It's very good for convos. I meant there is an actual new chat mode called Study.
Oh, interesting. That's a good thing too.
87 says it pre-prompts it for teacher-student dynamic.
Oh, gotcha. I probably have to look into that, because I'll often like pre-prompt it with saying like, please do not show me code, but let's go over this in words, because sometimes it does forget and like it'll like spam some code out first, and I'll quickly stop it so I don't get spoiled and then whatnot. So if there's some predetermining filters, that could be cool too.
The Quinogene 87 says when you start a new chat you click Tools, Study. The Quinogene 87 says yup, exactly.
Yeah, it's really, honestly, you guys, like ChatGPT, it's no different in my opinion than me. Honestly, these are the same exact questions I would go ask and write down in my notebook and go ask my TA after lecture the next time I would see, like the next Tuesday in class. Like I would go home, do homework, figure out some questions I had, write them down, and then go ask them. Right now, I don't have to have that time gap in between. I can get those same answers. And yes, there is some filtering you need to do, because not always is the answer going to be on. But for these more conceptual type of questions that don't have a lot of like hard level math involved, or like they're fairly straightforward, like conceptual understanding questions, like it'll give you the right answer a pretty good number of the time. And so, but there are instances where you need to be careful, right? Of course, with anything you take information from. Okay.
Quinogene 87 says 100% full agree.
Yeah. These are no different than the type of questions I would go take to my professor. And he would never just write the code for me, right? The professor would never sit down and just write the code while I sat there over his shoulder, right? I'm assuming, or write the chemical equation, or write the synthesis. He would sit there over my shoulder and then be like, what if you did that way? What if you move that there? Try that. And then you would go do it. What if you just move that there? And then next thing you know, you're learning, right? It's the same exact process. It's all about mindset and how you view it. Okay, does the brute force algorithm return the optimal solution? Why or why not? This is interesting. Does the brute force return the optimal solution? Now, we evaluated every possible partition. So we evaluated across every solution, no? At least for this type of subproblem. And we evaluated across a minimum. But the partition order then doesn't matter, right? So you could take any of the cows in that order. Let's have a conversation. Let's say, I'm gonna use the talk mode here. This is what I like to do sometimes. You can get a lot better. You can get a lot better prompts if you guys use the talk, and you guys can really have a conversation. Let's talk about the brute force algorithm and if it returns the optimal solution and why or why not. My first thought when thinking about this is that, well, when we're evaluating across partitions, we're evaluating across every possible combination of trips that we can make for these cows. And if we're evaluating across every possible trip, exhausting all possible angles, and then finding a minimum amongst those, wouldn't we be finding a optimal solution? Now, the order of which the trips take place, doesn't necessarily matter, but that could, potentially play a role as well. In some circumstances, I can imagine but the overall time won't be affected. Anyways, I would think that it would, but maybe it, I'm not sure, really. I'm honestly, I don't know. I'm on the fence. It's okay to be on the fence. I don't really know. It's okay to admit we don't know. You're thinking this really well, and you're right to focus on the fact that brute force exhaustively explores all possible groupings of cows into trips. Let's clarify with a definitive answer. Yes, the brute force algorithm does return the optimal solution. It tries every possible way to divide cows into valid trips, and it chooses the one with the fewest trips that meets the weight constraint. But it checks all possible combinations. It is guaranteed to find the best, minimal possible number of solutions. You're totally right to focus on every possible combination of trips. Your intuition about trip order not affecting the total trip is also correct in this problem. Only grouping partition matters. You wavered at the end, which is natural, but you actually had the right reasoning early on. So trust your logic here. Trust ourselves. Trust yourself. Okay. Yes. The brute force algorithm does return the optimal solution as it evaluates the conditions across all possible combinatorial
Chris
trips.
says, if you download the Read Aloud Chrome extension, you can highlight text and have it read back 1.5 times speed.
Does return as it evaluates conditions across all possible combinations of trips. Tries every possible way to divide cows into trips. And returns a value, an answer that best satisfies something like this. Brute force algorithm returns the optimal solution because it evaluates all possible combinations of trips and selects the one that best satisfies the weight limit and minimizes the number of trips. Satisfies the weight limit in the number of trips. Like that. Cool. All right, sweet. That was part A, you guys. Awesome. So we just completed part A of MIT 6.0002, the problem set 1. This was a really fun problem set. I did learn a lot, got some review on some file IO and stuff, and got some more, investigational, deep diving into more about what the read lines actually does and how to, better remove some of those delimiting characters at the end of them within that first PSA 1 here, which was pretty nice. Let's go ahead and exit out of this. Right, we opened up the file here and we stripped it out and then converted into a dictionary of cows with weights as their values. Then we did a greedy algorithm over this where we selected specific cows based on the heaviest cows first. Then we implemented a brute force algorithm where we analyzed all possible combinations of trips to make to transport these cows and selected the trip or partition with the least amount of trips in it, which was really cool. And then we just compared these two functions together by cross-referencing their time deltas against one another, and then computed a percent change against that to determine that, the algorithm for the brute force is significantly slower than the greedy algorithm, almost over 1,000,000% slower here. So it's a fairly large difference in just the smaller number of outputs, right? Or inputs, number of inputs. And then we solved a few questions here, kind of analyzing our results, and then over the greedy algorithm and the brute force algorithm. and kind of what we think about them. So thank you guys so much for being here and hanging out with me tonight. I will be back tomorrow to continue on with probably part B of this. We'll finish this up tomorrow and get part B done. And then we'll be moving on to lecture number 4. So if you guys are wanting to continue and take this course with me, please join my Discord link down below, completely for free, where you can access all of my resources and a roadmap of this course where I'll be uploading week by week breakdowns as I complete it. And obviously I'm re-uploading, streams to my YouTube channel as videos for the lecture watch along. So as we watch lectures, I think it's a lot more fun to watch these kind of lectures if you're watching them with somebody. So I'm re-uploading my streams of kind of like reacting to the lectures in kind of like a reaction format, while also taking notes. So I think it's a lot more, beneficial as a student to learn with a peer watching a lecture, and it might actually help you keep you focused and learn more and absorb more from the lecture too. So if you guys are interested in that, please check those out. I think they're really great resources to learn if you have ever wanting to kind of take this course as well, to watch it with me. Anyways, I appreciate you guys being here. So please come back tomorrow where we'll finish up problem B of this problem set 1. And then we will go ahead and probably in the stream after that continue on with lecture 4. So we're moving right along with this course, you guys. Thanks so much for being here. I will see you guys tomorrow. Please join the Discord and message me if you have any questions and want to talk. And please subscribe if you're new. I'll see you guys tomorrow. Bye. Have a good one.